सो आज हमें शुरू करना है बायरफ्रिंजेंस और डबल रिफ्रैक्शन। स्टार्ट करते हैं फिर। इट्स अ लिटिल बिट इम्पॉर्टेंट टॉपिक, सो थोड़ा ध्यान से पढ़ना। ठीक है, सो बायरफ्रिंजेंस, डबल रिफ्रैक्शन या फिर इस तरह का फिनोमेना यू माइट आल्सो स्टडी इन योर इलेक्ट्रोमैग्नेटिक थ्योरी. So in some courses, there is usually a component of electromagnetic theory in the third year or maybe second year. I don't know now what is the syllabus, but usually there is some study of that how light or an electromagnetic wave propagates through crystals which are birefringent in nature. So, but the nature of the depth of discussion that is expected in that EMT theory wala portion is extremely mathematical and बहुत detail में होता है. But for optics, we don't have to go in that detail. We only have to understand that what is the phenomena and how this phenomena will help us in changing the polarization state of a light. So abhi tak what we have studied is we studied that how I can have two plane polarized beams and how I can combine them to produce different types of other polarizations. Okay, that was the first topic we discussed. Then the second topic we discussed was that how we can use a polarizer and convert an unpolarized or natural light to a plane polarized light, and how we can apply Malus law. So that was the second topic we studied. So now the third topic is that I want to change the state of polarization. So basically जो first lecture में पढ़ा कि दो plane polarized beams हैं and I'm introducing a certain phase difference in one of those beams so that I can get either circular polarization or elliptical polarization or any other type of polarization. Okay, but now we want to study today that how do I actually introduce that phase difference between these two beams. Okay, so birefringence, so there are certain crystals which are naturally occurring which have a certain type of birefringence associated with them. So what is birefringence or what is double refraction? So it all comes down to a simple phenomena that these crystals are anisotropic. So isotropic means that whatever property you consider. For example, for us right now, the property of importance is refractive index. So we are going to look at what happens to the refractive index. So if I will have an isotropic material, an example would be glass. Okay, जो normal glass होता है, it's an isotropic material. उसका जो भी refractive index होगा, refractive index of glass, this is going to be same in all directions. So whenever I use isotropic word, what I mean is that irrespective of in which direction I am, going inside the crystal. So when I mean that I am going inside the crystal, what I mean is that at whatever angle the incident light is propagating inside the crystal, immaterial of that, it will always experience only one type of refractive index, which is constant for that particular material. So glass ka kuch refractive index hoga. So irrespective of at what angle the light is, incident on the glass, when it will propagate through the glass, it will always experience a refractive index equal to Ng, or the glass refractive index. So for these kind of materials, we define Snell's law. So Snell's law is applicable for an isotropic material. So these materials में क्या होगा, that light would follow Snell's law. So what is Snell's law? अगर मेरे पास कोई interface है, that interface से I mean that I have a certain boundary which is separating two mediums. So I have some boundary, or I can say I have some interface, and I have, let us say, some air over here and maybe glass over here. So then Snell's law tells me that if this is my normal, so if my incident ray is falling like this, then I would have, it would be making some angle theta 1, let us say. So this is my incident beam. And then I would have some part of it would be, reflected back at the same angle theta 1. So this is some reflected beam. But some part of it would actually, would pass through this, would pass through this interface and would travel through this other medium glass. Okay, so now there is one acronym which you can remember. Let me write with this. So I remember like this. Okay, so you can remember this word draw. So what this means is D stands for dense, R stands for rare, and AW जो है, it stands for away. So what this means is that if I'm moving from a denser medium to a rarer medium, then the reflected light would bend away from the normal. Okay, so right now I'm going from a rarer medium to a denser medium. That means that the reflected light should actually bend towards the normal. So now this is my reflected light. It is making some angle theta 2 over here. Okay, so like this, मतलब ये इसको हम याद कर सकते हैं. It's an easier way of remembering. Whenever you have to think कि in which way the light would bend, just remember this: denser to rarer away from the normal. So for rarer to denser, it will be towards the normal, like that. Okay, so I remember it like this. So here, Snell's law क्या बोलता है? Snell's law tells us that if the refractive index of air is, let us say, N1, and the refractive index of glass is equal to N2, so Snell's law states, so Snell's law के actually ये सारे components हैं जो अभी हमने discuss किए, कि जो incident light, reflected light और जो refracted light है, this is refracted, all of them are going to be in one plane. Okay, and the second, that is the first Snell's law, that all of them will be in the first in a plane. The second is that this angle of incidence is going to be equal to the angle of reflection. And the third law which we always write is that N1 sine theta 1 will be equal to N2 sine theta 2. So what this means is that if I will calculate sine theta 1 divided by sine theta 2, so I should get N2 by N1, which should give me some constant value. Okay, because currently I'm considering an isotropic medium which has a constant refractive index. Okay, so this is what Snell's law tells us that how the beam would refract inside an isotropic material. But when we discuss an anisotropic material, then this Snell's law would not hold true. So currently I only want to deal with an anisotropy in the optical properties of the material. So I am not interested in any other property of the material. Baki sab properties mein bhul jaungi. I just want to consider a material which has some anisotropy in its optical properties. So specifically, I mean that I might have some material which has different refractive indices in different directions. Okay, so then Snell's law would not be applicable directly, because now it would be dependent on at what angle the light is falling. So what path the light is taking inside the material, and depending on what path the light is taking, the the refractive index it would experience would change. So birefringence simply means that I have some crystalline substance, I have some crystal, naturally occurring crystal, which has some optical anisotropy associated with this. So birefringence would mean that I have some kind of a crystalline substance. Example of this would be even ice can show, mica, quartz, calcite, sugar crystals, tourmaline. These are naturally occurring crystalline substances which are optically anisotropic. So there is an inherent anisotropy, या फिर different type of nature associated with the directions, that in which direction the beam is propagating, it is experiencing a different refractive index. Okay, so optical anisotropy means that the optical properties are not same in all directions. So this effect birefringence से ही related है, double refraction. Sometimes they are used interchangeably also. But what happened was this person, Erasmus Bartholinus, he was the first person, and he observed this, that if you take a calcite crystal and some light is incident on this calcite crystal, so out of the crystal, see, if you take a glass slab and if you incident some light, let us say kuch ek chota sa beam I incident on the glass slab, so I will get only one image on the other side. Okay, but what he observed was that if he would take a calcite crystal and a light is incident on the calcite crystal, so on the other side of the calcite crystal he observed two images. So then he thought that, okay, why am I getting two images? And on further investigation, he found that what happens is that once your beam is incident on the interface, so at the interface of air and calcite itself, the beam actually breaks up into two parts. So now it is not refracted as a single beam. Just say isotropic ka, I just draw this diagram. So I know that incident light came and only one type of a refracted light I got. But what he found was that if I take that this is my air, and if I take a calcite crystal over here, and if this is my normal, so when the incident light passed through this interface or this boundary, so he observed that actually instead of having one refracted light, there were actually two beams. And these two beams of light, basically the light split into two components, and these two components generated two different images at the other end of the calcite crystal. So this phenomena, that one single incident beam is getting split into two refracted rays, not waves, gets split into two refracted rays, is known as double refraction. Okay, so this is known as double refraction, because now the incident beam has split into two refracted rays rather than just one ray. So this is my incident beam. And what he observed was that out of these two beams, he called one of the beam as an ordinary beam and one of the beam as an extraordinary beam. Okay, so let us say this is my ordinary beam, or ordinary ray he called. It is also known as O ray. Okay, and the other he called an extraordinary ray, which is also known as the E ray. So why did he give them these names? Actually, he later on found that your ordinary ray would always appear to follow Snell's law. So Snell's law abhi humne discuss kiya, which was this one. Basically, it always followed this kind of a relationship. That means that one part of this refracted ray, which was traveling as an ordinary ray, felt that the material, the calcite, is like an isotropic medium. It always felt like that. Usko calcite में कोई anisotropy feel ही नहीं हुई. So that's why we said that it's an ordinary ray. But the other part of the beam, refracted beam, which we are calling as the extraordinary ray, this is being called extraordinary because it does not follow Snell's law, because depending on, what is the angle it makes with a certain direction, एक crystal के अंदर एक अपना axis defined होता है, which is known as optic axis. So depending on at what angle this extraordinary ray is making with the optic axis, it experiences or it propagates with different velocities. Okay, so effectively the nature of the nature of propagation of this ray, that how fast it is moving or how slow it is moving, is very much dependent on what angle it is making inside the crystal with an optic axis. So we'll discuss what is an optic axis. Right now you can imagine that I have some crystal and there is some direction, some axis, some plane is defined. So with that optic axis, there is some angle which this extraordinary ray is making. And if I change that angle, okay, then the nature of, how fast it moves, how slow it moves, or what is the value of the refractive index it experiences are slightly, changing. So this is the ray which will not follow Snell's law, because Snell's law mein humne kya padha, that if I will take this sine theta 1 divided by sine theta 2, and because n2 and n1 both are constants, so the ratio should come out to be constant. But here for the extraordinary ray, because depending on in which direction this ray is propagating, which will be in a way decided by the incident light. So incident light ने कैसे hit किया interface को, और फिर extraordinary ray किस direction में move करी, all those things will influence the amount of refractive index it would experience, and therefore the Snell's law would not hold true for all directions. So I might have some relationship for one angle, some relationship for other angle. So in general, we would say that the extraordinary ray would not follow Snell's law, and that is why we are saying ki it's extraordinary. That is why the name is like that. Okay, but for the ordinary ray would never feel that it is in an anisotropic medium. Ordinary ray would always feel that, okay, I have same refractive index in whichever manner I want to propagate. So it doesn't matter. Okay, so you can make a note here that or maybe let me write what is double refraction. So double refraction means the splitting of incident light into two while crossing a boundary या फिर interface between two materials is known as double refraction. Okay, so the double refraction में क्या होगा, that one of the beams gets refracted according to Snell's law and behaves like a ray refracted from an isotropic medium. Okay, so this is called as the ordinary ray. And जो second ray है, the other beam does not follow Snell's law and therefore called extraordinary. वैसे एक तरह से we should have named it something else, you know, because ordinary means what? Normal. So extraordinary वैसे क्या मतलब होना चाहिए? Extra normal, but we use extraordinary in a different sense. By extraordinary, we always mean it's special.
इसका रीजन मैंने ये पढ़ा था कि because the ordinary ray follows ordinary laws of reflection, that is why it is known as ordinary ray.
Yeah, that is what Snell's law is all about, right? Snell's law only tells us the laws of refraction. No, I'm saying the word, I'm talking about the English, not about the physics right now. I'm saying that ordinary would mean like a normal ray. Everything is normal. So the word extraordinary should mean it's extra normal. But in English, extraordinary means special.
Yes.
Right? No, matlab, I'm just deconstructing the word, that extraordinary. Are you understanding what I'm saying?
Yes, ma'am.
English is like a funny language in that sense. If I know what is the meaning of extra.
ऑर्डिनरी का सेंस ये होता है कि अगर हम किसी चीज को ऑर्डिनरी कह रहे हैं तो फ्रॉम आवर नॉर्मल डे टू डे पर्सपेक्टिव हमें उसके ट्रेड्स पता है एंड द थिंग फॉलोज द सेम ट्रेड एज द अदर थिंग्स लाइक इट डू. जैसे अगर हमको पता है कि एक डेस्क है तो हमें पता है बाकी डेस्क चीजें रखने काम आती है, ये भी रखती है, तो ये ऑर्डिनरी डेस्क है. लेकिन अगर उसमें कोई ऐसा ट्रेड है जो हमें नहीं दिखता नॉर्मली, तब उसको एक्स्ट्रा ऑर्डिनरी बोलेंगे. देयर इज समथिंग एक्स्ट्रा इन इट. तो इसमें भी तो सेम चीज है.
I know that. I'm not saying that. What I'm saying is that extraordinary का मतलब English में होता है something special, right? That it has something which the others don't have. But what I'm saying is that if I deconstruct the word, तो extra का मतलब होता है ज़्यादा, ordinary का मतलब होता है normal. तो English में it should have meant कि something which is more normal than the ordinary, but it means the opposite. So it's a commentary on the English language, not the physical meaning of it.
Yes, ma'am. Yes, ma'am.
That English is funny that way. Extraordinary would mean something which is better than the ordinary or special than the ordinary. So this is the ordinary way. There is one more thing, but maybe I should put the figure first. Okay, so let me insert the figure. Okay, I have some question. No, I just had a comment. ठीक है, so this is one experiment जो कि lab में भी किया होगा using a calcite crystal. नहीं किया है तो it will help us, you know, sort of clear certain things. So ये experiment usually होता है lab में, 12th में भी होता है in fact. So let us see what is happening here. So what is happening is जो extraordinary और ordinary ray होता है उसका एक और property होता है that both of these rays are plane polarized. So you can mention it, you can actually write it here that both E ray and O ray are plane polarized. So this is a property कि अगर मैं कोई भी बायरफ्रिंजेंट मटेरियल लूंगी, कोई भी ऑप्टिकली अनआइसोट्रोपिक मटेरियल लूंगी, which is undergoing some kind of, which is making the incident beam undergo some kind of double refraction. So my extraordinary and ordinary ray will come out to be plane polarized. Okay. So यहाँ पर what is being shown is that I have some unpolarized beam which is falling onto a calcite crystal, and it is now breaking into an extraordinary ray and into an ordinary ray. Okay. And corresponding to that, I will get two images. यहाँ पर I'll get an image and यहाँ पर I'll get an image. So one image is being formed by the extraordinary ray and the other image is being formed by the ordinary ray. But now the special part, like the special thing is that, if you notice, जो मेरा E ray है, उसमें the polarization is shown like this, okay, like a straight line. So what this means is that जो मेरा E ray है, this is actually also called as P polarized. So I'll just write that. So जो E ray होता है, after passing through a calcite crystal, okay. So I'm currently only talking about calcite crystal. So this E ray is P polarized. So what do I mean by P polarized is that the electric field vibrations of this E ray are parallel to the plane of incidence. So P polarized means that parallel to plane of incidence. So if this is my calcite crystal, if my hand is my calcite crystal, so P polarized would mean that the electric field is oscillating like this in the plane of my hand, okay? But if I look at the O ray, so I see that it has been shown, the polarization is being shown as dots. So now that is known as S polarized. So S means that perpendicular. So if this is my calcite crystal, so my electric field would now oscillate like this, perpendicular to this plane of incidence. So let us write that also. So my O ray is also called S polarized. So that means that perpendicular to, you are understanding what I mean parallel and perpendicular. I mean the electric field vector ka vibration, okay? So it is perpendicular to the plane of incidence. So this is another terminology which you should try to remember, because sometimes E या O के लिए ही नहीं, but other questions में भी हो सकता है that the input light is S polarized or you have a P polarized input light. So एक तो plane polarized के वो हमने कैसे denote किया था? We said it was a P state, okay? So these are different terminologies. P state means a plane polarized light जिसका फिर कुछ orientation given होगा. But if it says that I have a P polarized light, then already the orientation of the electric field is given to me, that it is in the plane of incidence. If the question says the incident light is S polarized, then also I have to consider that the electric field is now perpendicular to the plane of incidence. Okay, so these terms also I should know. So now what this diagram is showing is that I have a polarizer PP dash. So here PP dash is a polarizer, and I can rotate the pass axis of the polarizer. So I can rotate this polarizer like this, okay? And what will happen is, as I will rotate the polarizer, so if the polarizer is pass axis is parallel to the plane of incidence, then only the E ray would pass and the O ray would be blocked. And if the plane of polarization, if the pass axis of the polarizer is actually parallel to the S polarized ray, okay, that means it's perpendicular to the incident plane of incidence, then only the O ray would pass and E ray would be blocked, okay? So this is a famous experiment to see that, what is the polarization of the E ray and O ray. So if I already know that how the pass axis of the polarizer is aligned, so I can also find out that what is the state of polarization, that how the E ray is polarized and how the O ray is polarized. But another thing that this experiment is showing is, if you see figure number B, okay, so उसमें क्या किया है हमने, that rather than अब polarizer को फिलहाल के लिए भूल जाओ, ठीक है, तो अब what we have done is, ये जो axis है, if you see the axis n dash, basically this axis जो है, so the calcite crystal itself is rotated about this axis, okay. So what will happen is, because O ray is directly going straight, so the image which O ray is producing would always be, produced here in the center of this plane. But the image which is being produced by the extraordinary ray, the E ray, would actually rotate as I will rotate my calcite, okay, because it's going at an angle. So as I'll rotate my crystal, that image will also rotate as I'm rotating the crystal. So that is another sort of characteristic associated with double refraction. I've taken this image also. Maybe I'll put it so you can see किस तरह का होता है. So this is a typical double refracted image. So one of this image is produced by the you just look at the image directly produced inside the crystal, okay. So you can see 2 calcite written. Do not right now look at the images produced outside, okay. Just look at the images which are directly, you can see through the crystal. So you can see 2 calcites written, एक slightly ऊपर है, एक slightly नीचे लिखा है. So one of these is being formed by the extraordinary ray and the other is being formed by the ordinary ray. So this is how typical double refraction looks like. So now that we sort of, yes.
वो सर्कुलर है या फिर वो एलिप्टिकल है, वो जो बनता है ई रे का?
क्या चीज?
ये पीपी डैश पे बन रहा है ना,
ये तो उस पे डिपेंड नहीं, ये सर्कुलर ही है. मतलब it will depend on how you have cut the crystal also. If the crystal is big enough and you can do the complete rotation, so it would move in a circle, because this angle is not going to change, this angle, because this incident light is still coming normal. So this angle would always remain same, but you are rotating the crystal. So it will, समझ रहे हो? So it will form a circle there. इस figure में लग रहा है it's an ellipse, but the image would move in a circle because this theta is not getting changed, because input light is still coming normal to the crystal. I am not tilting the crystal, I am keeping it fixed, but I am rotating it. So this incident light ka angle change nahi ho raha hai. So this theta is fixed. So I will get an image which will move in a circle around the central image, which is formed by the ordinary ray. Okay. So now let us write few other things about this. So another point that we should know is, because the ordinary ray behaves like, it is seeing an isotropic medium. So the velocity of ordinary ray is same in all directions. And V naught, the O or naught here signifies the ordinary, would be equal to this. So this is same. So what is N naught? N naught is the refractive index. So now these two beams, the ordinary beam and the extraordinary beam, would experience different refractive indices. Okay, so this is the refractive index. Experienced by O ray. Now, similarly, what will happen is that जो velocity होगा extraordinary ray का, ठीक है? So the velocity या फिर speed, यहाँ पे it's more like speed. Direction भी नहीं discuss कर रही मैं. So speed of जो E ray है is not same and varies with direction. In different directions, it would have different speed. and its value will lie between this V0 to VE. Okay, so VE कैसे define होता है? So we define some extraordinary refractive index as NE. ये हम कुछ define करते हैं for that crystal, and then we define VE as C by NE. Okay, but this is one extreme. अब जरूरी नहीं है that the extraordinary ray should move slower or faster. So it can take any value depending on what crystal you are taking. So in some crystals, the extraordinary ray might travel faster than the ordinary ray. In some crystals, it might travel slower. So there is no rule like that, but its speed would always be bounded by these two values, V0 and VE. अब it would vary कि V0 ज़्यादा है, बड़ा है, या VE ज़्यादा बड़ा value है, depending on the crystal we have. Okay, so in calcite, VE is actually greater than V0. Okay, and ये जो हमने दो refractive indices define करे, N0 and NE. So if I will calculate the difference between these two, so the difference between these two principal refractive indices, N0 and NE, is known as birefringence of the medium. So then birefringence is basically nothing but this difference between these two values. अब इसमें भी जरूरी नहीं है that NE should be greater than N0. NE can be less than N0 also. So you can have delta N, which is negative, or you can have delta N, which is positive. So you will have some kind of, positive crystal or negative crystal terms like that. But birefringence in general would mean that these two refractive indices, N0 and NE, if I take their difference, that will tell me that how birefringent the material is. Okay. So, yes.
Ma'am, NE is not constant, right? It varies upon the direction.
Which thing?
Like
NE. Yes.
Yes,
So this NE is defined across one particular axis. So this is I think the maximum amount of NE that can go, but it will vary in a certain sense, but we don't have to go in that nitty gritty detail. हमारे questions में उतना detail में नहीं आएगा. That's why I said initially that ये बहुत detail में EMT में cover होता है. But हमें अभी फिलहाल के लिए question जो आएगा उसमें NE का एक value दिया होगा. But I'm going to write one formula for velocity. So ये जो refractive indices define होते हैं N0 and NE. So this NE is more like, a general value देते हैं, but it is different. Yes, at different sort of, the overall. Let me write the formula for the velocity. जब मैं velocity का formula लिखूंगी तो effective जो refractive index beam experience करेगी, that is going to be dependent on the theta. So let me come to that. Just give me 1 second, okay? So the velocity for the extraordinary ray actually follows this formula. Okay, so here what theta means is that there is some particular direction defined inside the crystal. So अगर मेरे पास में ये crystal है, let us say, this is the face of the crystal, and let us say this is my optic axis. So optic axis is more like a direction. It's not an axis per se, it's a direction. Okay, so let us say this is x direction here, which is the optic axis. So what this means is that if my extraordinary and my ordinary ray are are parallel to the optic axis, they are moving in the direction of the optic axis, then even the extraordinary ray would have the same velocity as the ordinary ray. So an extraordinary ray would start behaving like an ordinary ray if it is moving parallel to the optic axis. But if my ray is, let us say, making an angle, that it is making some angle with respect to, see, all these are parallel planes I've drawn. So if I take this theta, so this is this theta, that what is the angle my E ray is making with respect to the optic axis, which is defined for a crystal. Already hota hai crystal ka ek specific optic axis. So what angle this E ray is making with respect to the optic axis is theta. So now depending on this theta, the velocity of the E ray has to follow this relationship. Okay, so this velocity which I earlier defined is more like a specific case of this. So see, if my theta is actually equal to 0, that means that E ray is going is parallel, the direction of the E ray is parallel to the optic axis. Then what will happen is, from this equation, let us say, so if theta is equal to 0 degree, then VE is actually equal to C by N naught. So which is same as the ordinary ray. Okay.
मैम ये थीटा रिफ्रैक्टेड एंगल है.
Theta, no, theta is the angle which this beam is making with the optic axis. But जब हम crystals बनाते हैं ना, तो optic axis को हमेशा parallel to the plane of incidence choose कर लेते हैं. जैसे एक crystal है, हम उसको अपनी मर्जी से किसी भी तरह से we can cut the crystal, we can shape the crystal. So we always cut the crystal in such a manner that this optic axis is parallel to the plane of incidence. So in that case, this theta would be like a refracted angle, only in that case. But if the crystal is not shaped like that, so then this theta is the angle which the ray would make with the optic axis. So ये थोड़ा मुश्किल होता है समझना, I understand that. But what you have to think right now is that if I have a crystal and this optic axis जो है, उसी के parallel मैंने plane of incidence काटा है. That is how I have cut my crystal. So that when the light falls, okay, when the light falls, and if the light is sort of, one component of the light sort of moves in parallel to the optic axis, and one component would move perpendicular to the optic axis. Abhi I'll discuss those cases. So then, depending on how the light is interacting with the optic axis, this theta is going to be different. It will not always be the angle of refraction. In certain cases, it can be, but in most cases, you will have to sort of look directly that what is the angle this beam is making with optic axis. हमेशा refraction angle के equal नहीं होगा ये. Because anyway, E ray जो है वो Snell's law follow नहीं कर रही है. Starting में ही मैंने बोला. तो जैसे इस वाले डायग्राम में हम जाएंगे पहले वाले में. So this ये वाला जो theta है. Okay, so this theta is the theta if I consider my optic axis to be, parallel to this plane. If I consider that this is my optic axis, that means optic axis is going like this, then this theta, the theta this ray is making with respect to the optic axis. So this is not, you cannot find out this theta by using Snell's law. That is what I discussed initially. So in a way, it's the angle of refraction, but it cannot be directly derived like that. So this theta would be given to you if a question like this comes. Are you understanding? Because there are multiple small things you have to keep in mind. So this is the angle of refraction, but not the angle you will get from Snell's law. And this is the angle of refraction only if the optic axis is parallel like this, okay? But if the crystal is cut in a different way, that optic axis is maybe not like this, but optic axis is maybe, going in this direction, right? Then theta would be this angle. So this theta would always be calculated with respect to the optic axis. क्योंकि ये analysis जो है, ये formula जो है, वो उसी sense में derive होता है. So if I will consider the case that theta is equal to 90 degree, that my E ray is actually making a 90 degree angle with the optic axis, then what will I get? I will get VE is equal to C by NE. So ये जो दो ऊपर formulas मैंने लिखे यहाँ पर, so this is like the case, this is like that axis, which is exactly, this is the velocity of the ray when the ray is actually traveling perpendicular to the optic axis. So with these formulas, I am just defining the two extremes, that what is the V naught, what is the VE. Okay, so this is the value of VE like that. But if I consider any other value of theta, then ये जो velocity होगा, I'll have to incorporate both sine square theta का value भी, cos square theta का value भी, and I'll have to evaluate this whole term, and that will give me some value of VE. Okay, so in that case, VE ना तो directly NE से आया, ना directly N0 से आया, बल्कि ये equation solve करके आया. So in that sense, we say that the light is experiencing different refractive index at different thetas because it's following this kind of a velocity relationship. Okay, so जो ऐसा हम मतलब फिर corresponding to this, I can define a different function of refractive index also. Right now ये जो है इसके corresponding, maybe I can also write some relationship as a function, this n as a function of maybe theta. I don't know, I have not read it, but are you understanding what I'm saying? Currently, I've only told two values of N0 and NE, which I can calculate by certain means. And I find out that the velocity follows this kind of a behavior. So now at a different theta, I will put the value of sine theta and cosine theta, and it will give me some value of VE. I will calculate this term. So effectively, VE has seen some refractive index, which is different from NE, which is different from N0, but it is coming from this relationship. So that is why we say that depending on different theta, the wave experiences, the extraordinary wave experiences different value of refractive index. And these are the two extreme values. So isko हमने क्या लिखा था? This is equal to V naught. That is why I said that the velocity of the extraordinary ray would always fall between V naught and VE. So these are the two bounds. Now, depending on whether N naught value is greater than NE or NE is greater than N naught, I will get V naught greater than VE or VE is greater than V naught. Okay, so I'll have a positive crystal or a negative crystal like that. But in your exam, if a question like this comes, you would be given, क्या होता है मैं बताती हूँ, या तो birefringence दिया होता है, that they will tell you the difference between NE and N0, or they will tell you what is NE and N0, and they'll ask you to calculate certain things or calculate the path difference, optical path difference, and those things. So we will cover that. But for us right now, only for understanding what are retarders and solving these kind of questions, this much background is enough. But what you have to remember is that हमेशा जो ये थीटा होगा वो ऑप्टिक एक्सिस के रिस्पेक्ट में कैलकुलेट होगा. इट इज नॉट एनी अदर थीटा. ऑप्टिक एक्सिस का क्या ओरिएंटेशन दिया है, what is being told in the question, like that we have to choose theta. Okay, so this should be at least clear to us. And the second thing that should be clear to us is that the ordinary ray and the extraordinary ray are actually plane polarized. One of them is P polarized and the other is S polarized. वो हमें पता होना चाहिए. ठीक है, उसके बाद में ठीक है. सो ऑप्टिक एक्सिस बेसिकली फिर क्या हो गई, ऑप्टिक एक्सिस एक वो डायरेक्शन हो गई क्रिस्टल के अंदर जहां पर एक्स्ट्रा ऑर्डिनरी रे एंड ऑर्डिनरी रे दोनों की दोनों सेम स्पीड से ट्रैवल करेंगी. सो एनी डायरेक्शन इनसाइड द क्रिस्टल when both of these rays travel with the same speed is known as optic axis. So there are two types of crystals. एक crystal होता है जिसमें इस तरह की एक ही direction होती है, which are known as uniaxial crystals. So uniaxial crystals have only one direction inside them, in which the E ray and the O ray can travel with the same speed. But there are also biaxial crystals, जिनका मतलब description थोड़ा और मुश्किल हो जाता है. So in biaxial crystals, there can be two directions inside the crystal, because it's a 3D crystal. So there can be any two directions defined inside the crystal, in which the E ray and the O ray travel with same speed. But for us, only the uniaxial crystal matters right now, because we are studying this because we want to understand the working of a half wave plate and a quarter wave plate, and a full wave plate to kaam nahi aati. But these two we want to learn and we want to understand their principle, इसलिए हमें सिर्फ uniaxial crystals ही पढ़ना है, ठीक है? But from an understanding point of view, there can be a biaxial crystal also, which has two optic axes or two directions in which E ray and O ray can have same speed. Okay, so maybe you can write it down somewhere that this theta is the angle E ray makes with respect to optic axis, and the Ne and N0 जो भी होते हैं, they are constants of a crystal. So there are certain ways to find them, and for a particular crystal they would have a certain value. Okay, this value is fixed, but like I explained, because velocity follows this relation, so effectively, depending on theta, the beam will undergo different, will actually travel with different velocities, and therefore effectively different velocities का मतलब है that it experienced a different refractive index. Okay, and और क्या लिखना था मुझे? हाँ, so optic axis क्या है वो लिख लेते हैं. That optic axis का definition लिख लेते हैं. So along a particular direction which is fixed for a crystal, the two velocities of O ray and E ray are equal. This direction is known as optic axis. Okay, so this is a direction. It's not just one particular axis. It's a proper direction. So wave can be traveling parallel to, for example, x direction hai. Us tarah se it's a direction. It's not just one line. Okay, so okay, it's also sometimes called fast axis. Okay, so question में काफी बार fast axis भी लिखा होता है, that the fast axis of the crystal is oriented this way, that way. So what basically they mean by that is still optic axis. Okay, so so if there is only one such direction, so uniaxial होगा, that it will have only one optic axis. So this would be calcite, and biaxial होगा, that it can have two optic axes. So this would be, I have not written an example, maybe, I don't know an example of this, I have not written right now. So ये book में पढ़ सकते हो, एक second, I had written which page to study. Okay, so if you want to understand more about this, and or maybe you want to read more about this, so you can actually read Ghatak 21.12. So यहाँ पर derivation है that you know why actually this phenomena is happening. So एक anisotropic medium में electromagnetic wave propagate करती है, तो how the electric displacement vector and the electric field, कैसे they change in an anisotropic medium compared to an isotropic medium, that full derivation is given here. So if you are interested, you want to read, so this is a further thing, but it is not required from the JAM point of view. This is only if you want to understand this further. But whatever I have told, अगर उतना भी आता है समझ में, you can solve questions. ठीक है. So now next एक ये diagram है, I think ये तो कर ही लेना चाहिए. ठीक है. So एक isotropic, because it sort of helps you visualize the wave fronts. Okay. So let us consider an isotropic medium and an anisotropic. So anisotropic में I can consider a negative crystal and a positive crystal. So example of a negative crystal is calcite and a positive crystal is quartz. Okay, so what do I mean by negative and positive is that for a negative crystal, Ne का जो value है, it's less than N naught, and therefore the Ve is actually greater than V naught. Okay. And for a positive crystal, Ne is greater than N naught, and therefore Ve is less than V naught. So this is how we define a positive and a negative crystal. So now if I want to compare them, so in an isotropic medium, if this is my source, okay, and the source is sort of emitting some light. So because it's an isotropic medium, refractive index is constant throughout. So जो भी ये light, जो भी मेरा ये point source है, इसने सारे directions में basically light emit किया, spherical wave sort of emit किया. So that spherical wave is going to move like a spherical wavefront, because each individual ray of this wavefront, irrespective of in which direction the ray is emitted, for example, one ray is going like that, one is going like that, one is going like, doesn't matter because it's an isotropic medium. So I get a wavefront which is like a circle. So if I can draw a circle. Move क्यों नहीं हो रहा? Okay, it's not moving, but okay. So what I mean is that I have, the wavefront. If I will consider an isotropic medium, so जो wavefront form होगा light का, that is going to be a spherical wavefront. Because the light is going to experience same refractive index in all directions, so it is going to move with same velocity, and therefore all of these rays would move forward in time with same amount, and therefore the shape of the sphere would be maintained. Okay, so this is one thing. But if I consider an anisotropic medium, और उसमें भी दो cases हैं, that I consider a positive crystal and a negative crystal. Okay, so now अब इसमें भी there are two waves, so we have to consider two wave fronts. So एक तो ordinary wave है which is forming some image, and there is an extraordinary ray which is forming some image. So there are two wave fronts which are moving. So one wave front corresponds to the ordinary ray, the other wavefront corresponds to the extraordinary ray. अब ordinary ray क्या है? वो तो ordinary है. It's going to behave how? It's going to behave like a normal ray in an isotropic medium. So the wavefront corresponding to the ordinary ray is a simple sphere, right? So let me draw another circle. So now this is the, let me write. This is the sort of my wavefront corresponding to the ordinary ray. But now if I consider that what will happen to the extraordinary ray, so because ये क्या है, it is a negative crystal, तो यहाँ पर VE, because NE जो है is less than N naught, so VE अगर मैं maximum value देखूं VE का, तो it's greater than V naught. So I know that you know, whatever I'm going to draw corresponding to the extraordinary ray should be bigger in size compared to the ordinary ray, because the velocity with which the ordinary ray is moving is larger. मतलब V जो उसका upper limit है VE हो गया है, which is bigger than V naught, okay, for a negative crystal. But now I also know that the velocity of my extraordinary ray is actually going to follow this relationship, that 1 by VE square is equal to sine square theta plus all these terms, right? So if I want to look that how this is going to expand in 3D, so what it is going to form is, in 2D it will look like an ellipse to me, because depending on theta, the values are going to be different at different places. But in a 3D, it's going to form some kind of an ellipsoid, okay? So in 2D, then I can draw it like this. But now why have I drawn it like this? The reason is because I didn't tell you initially, I am choosing that this is my optic axis. Okay, so now then this figure is correct. So when I'm choosing this as my optic axis, तो अभी हमने discuss किया था that when the theta cos theta is equal to 1, that is theta is equal to 0, that means my E ray is moving. This corresponds to the E ray. So my E ray is when the E ray is moving parallel to the optic axis. So that means यहाँ पे ये velocity जो है उसका, it should cut, it is going to be similar to V naught. Therefore, these two curves needs to overlap at these endpoints, because here ये जो दोनों का है, this is V naught only. And when I'm moving perpendicular to the optic axis, when the sine of theta is equal to 1 and cosine of theta is equal to 0, तो अभी हमने discuss किया था that this is then equal to VE. Okay, so this is just a visualization. So what you can write is that for the ordinary ray, I would get a spherical wavefront. I would get a spherical. And for an E ray, I would get an ellipsoid of revolution. Okay, I'll get some kind of a ellipsoid in 3D, and in 2D, it looks, the cross section looks like an ellipse. Okay, so similarly, I can draw this diagram for a positive crystal. So again, let me draw the two axes. Again, I'm choosing that my optic axis is like this. But now, because this is a positive crystal and NE is greater than N naught, and therefore VE is less than V naught, always remember this, that V naught is this and VE is C by NE. Okay, so अब क्या है इसमें, जो V naught है, that is larger. So only when I'm traveling, my E ray is also traveling parallel to the optic axis, सिर्फ तभी जो E ray है उसका velocity V naught के equal होगा. ठीक है, तो अब क्या होगा, ये ellipse sort of rotate हो जाएगा and it will come inside, because now छोटा हो जाएगा ये ellipse. So now what will I get, जो मेरा जो ordinary ray है उसके लिए I'll get a wavefront similar to before, that I'll get some kind of a circle. Circle नहीं लग रहा है, no, ठीक है, it's supposed to be a circle. Wait. Okay. So this is again the same wavefront which is being formed for the ordinary ray. So this is again the ordinary ray. But now what will happen to the wavefront for the extraordinary ray is it would become like this. Basically the ellipsoid का जो major axis है वो अब rotate हो गया है, क्योंकि अब क्या है, VE is less than V naught, therefore now this is VE and this is V naught, and यहाँ पर at these extremes the two curves have to touch each other, because then the VE is parallel. When the E ray is traveling parallel to the optic axis, the velocity is equal to V naught. Okay, so this is all we need to understand about anisotropic materials and their optical anisotropy. इतना भी पता है, बहुत ज़्यादा पता है, काफ़ी है इतना. उसके बाद में next what we have to study is, now we have to study the principle that how do we actually use these anisotropic materials to introduce some kind of a phase difference. Okay, कैसे हम polarization change करेंगे. So that is the next thing that we have to study now, and which is actually important. So इसको अगर आप लोगों ने already EMT में पढ़ा है ये सारे topics, so तो this is more like a revision, and you can, that means that you have already read much difficult books in this topic. But those of you who have not studied this in EMT, they can skip those difficult books, and only this much is necessary for optics at least. और electromagnetic में अगर चाहिए होगा तो फिर सर पढ़ाएंगे तो तब पढ़ लेना, ठीक है. अभी इसमें और ज़्यादा दिमाग मारने की ज़रूरत नहीं है, because the more books you will read for this, the more confused you will get. So if something is not clear, you ask me in the next class or whenever you get to revise this, or you listen to the lecture again, because this is all we need to know for our exam. हमें और ज़्यादा किताबों में दिमाग नहीं मारना है, बहुत ज़्यादा कुछ पढ़ने की ज़रूरत नहीं है, इतना काफ़ी है. So now what we want to study is that how do we introduce a phase difference in the beam, ठीक है. So अब इतना हमें समझ आ गया है कि दो रे है, डबल रिफ्रैक्शन हो रहा है, कोई बायरफ्रिंजेंट मटेरियल है उसमें डबल रिफ्रैक्शन हो रहा है, दो रेज फॉर्म हो रही हैं और वो दोनों रेज डिफरेंट वेलोसिटी के साथ ट्रैवल कर रही हैं. तो अगर दो रेज डिफरेंट वेलोसिटीज के साथ ट्रैवल कर रही हैं तो एक पर्टिकुलर टाइम में एक ज्यादा आगे चली गई, एक पीछे रह गई, तो दोनों में एक कुछ फेज डिफरेंस तो प्रोड्यूस हो ही गया, दैट वी कैन विजुअलाइज. ओके, because the velocities are different, so some kind of phase difference has been produced, right? But now what we have to study is that how different values of, how the different types of incidence and how the different types of phase values will give rise to different kind of beams. That is what we want to study now. So let us consider a calcite crystal or a doubly refracting crystal and a uniaxial crystal. We will only deal with uniaxial crystals. So let us consider a calcite crystal. So I'm drawing the plane of incidence for the calcite crystal. Okay, so I'm looking, the crystal is in the plane of the paper and I'm looking at its face, the face of the crystal. So now what I do is I choose some axis because I want to make my life easier. So let us define some axis. So I say that this is my X and this is my Y axis, and I decide to choose the optic axis to be along X. So I choose that this is the direction of my optic axis. Okay. So now some beam is incident on this crystal. So let us say this is the electric field, which is incident. So this is some plane polarized light, which is incident on this crystal. So this is some E field, which is plane polarized. And it is making some angle theta with respect to the optic axis. Okay. So now my optic axis is along X, but I can, always, matlab मैं कहीं पर भी, optic axis means that this everywhere there is optic axis. All these are optic axis. So अगर मैं कोई भी optic axis consider करूंगी, because they are parallel planes, so I can always find out this theta. Everywhere it is same. So optic axis is a direction, not one particular line. Okay. So यहाँ पे भी theta आएगा, यहाँ पे भी theta आएगा, like that. So I need to remove all this. और नहीं होता क्या? नहीं होता बाकी. So अब what we are doing is, I want to find out that where will I get an ordinary ray and extraordinary ray, कहाँ जाएगा, ठीक है? So I can take a component of this beam. So I can decompose this beam. इसका मैं कुछ x component ले सकती हूँ, and I can calculate some y component of this beam. Okay. So this is the x component, which is parallel to the optic axis in a sense. So x component is equal to, if I say that this is E, so EX को, so E field jo hai, it has some, because it's a plane polarized beam, so it has some field in the X direction and some part is in the Y direction, and it is a vector sum of both these two components. So I can write that I have some EX component. So यहाँ पर I have some EX component, and यहाँ पर I have some EY component of the field. So I say that EX component is equal to some EOX, and there is some sine omega t term. So this is actually immaterial, but because I'm writing a wave, so I'm writing this, we can remove this also. But I'm just saying that there is some sinusoidal time variation also, okay? And I can write some EY component to be equal to some EOY component, okay? Sign लिखी देते हैं इसमें. Then it makes sense more. So now if I look at the EX component, so जो EX component है, उसका polarization कैसा है? उसका polarization X axis के along है, and this is my plane, ठीक है? So it is parallel to the plane of incidence, parallel to the optic axis. But if I look the orientation of the electric field along Y, actually you have to sort of consider that. How should I make you visualize? But what I want to say is that जो Y का जो electric field है, it is sort of perpendicular to the optic axis, obvious है. So we will say that the electric field or the X component, which is in the direction of the optic axis, which is parallel to the optic axis, we will say that it is, we will say, what will we say? We will say that it is actually E ray, which is parallel. It is, iska jo vibration hai, it is parallel to the optic axis or the field of, or the plane of incidence. The beam is falling like this. So it is sort of parallel. Optic axis is along the X axis. So I will say that this is my E ray, and the other one, jo EY hai, जो EY component है, it is perpendicular to the optic axis. So I will say that the EY is actually my O ray, is the ordinary ray. So this is perpendicular to plane, or you consider in terms of optic axis, perpendicular to the optic axis. So I'm calling that to be my O ray. And if I'm not wrong, that is how we defined. So then my O ray is actually S polarized.
हेलो मैम,
Yes.
यहाँ कंसिडर किए कि प्लेन ऑफ इंसिडेंस और ऑप्टिक एक्सिस सेम है.
हाँ, in a way, that is what they are saying. But then वो visualization थोड़ा मुश्किल हो रहा है, इसलिए I am saying that only consider the optic axis. But the way optic axis has been, the way the crystal has been cut is that the plane of the incidence is parallel to the optic axis. Okay, so if the beam is falling like this, so this is the plane of incidence, and the optic axis is also parallel, is in this plane of incidence. It's not making an angle to the plane of incidence. Okay, so that is what I mean, parallel to the plane of incidence. Okay, so okay, so now I have an O ray which is S polarized. So you only remember that it is perpendicular to the optic axis. The E ray is sort of, the electric field is vibrating parallel to the optic axis. And now what we have to do is, now we know कि हम जो भी हमारा crystal है, we can choose the thickness of the crystal, that how thin or thick we want the crystal to be. So depending on how thick or thin the crystal is, the amount of phase difference between these two beams would change. Okay. So for, I'll just explain that, but let me just write this. So EX will actually going to behave like a E ray. And this is going to behave like a O ray, this component of the incident electric field. So now if I say that the thickness of the crystal is equal to some amount T.
Ma'am, the rays are moving in Z direction, right?
Yes, because wave is moving in the Z direction. Wave is moving like this. See, that is why I said that later on we get confused that how the wave is moving. Wave is moving through this plane. The electric field is vibrating like this. The K vector is perpendicular to the E vector, right? Wave moves in the direction of the K vector, not in the direction of the E vector.
Yes, ma'am.
Right? So that is why when I was describing that we should know in which direction the wave is moving, I knew, because here it gets a little bit difficult to visualize that how are we moving and where are we moving. So every time the wave, जो भी हमारा ray है, it's going like this. It's going through the crystal. It's going in the Z direction. But I'm talking about the vibration of the electric field. Always the vibration of the electric field is perpendicular to the direction of the wave propagation. Okay. So now I want to find out that what is the phase that my my beam is going to gain. So I have now two components. एक तो मेरा कुछ E ray हो गया, एक कुछ O ray हो गया. तो जो E ray है, it is going to experience a maximum amount of refractive index which is equal to NE, and O ray क्या होगा, will experience N naught. ठीक है. So I can find out phase gain कैसे निकालते हैं with respect to distance. Phase gain, if you remember, हम equation में K X लिखते थे, but now it's moving in Z direction, so K Z. And Z is equal to what? Z is equal to T. How much distance we have moved inside the crystal, that is equal to the thickness of the crystal. So phase gain is simply equal to KT for one wave. Okay. So phase gain for E ray क्या होगा? हो जाएगा 2 pi by lambda naught. Lambda naught would be the value of the wavelength in free space, or in an isotropic medium, you can consider more like a free space. And एक जो E ray है वो NE का velocity से जा रही है, because I have to, this is what lambda E होगा ना, will be equal to lambda naught by NE. So that I have substituted that what is the wavelength the E ray would experience due to the this refractive index, and then it is moving a distance t. So this is the phase that E ray is going to gain. So similarly, the phase gained by O ray is going to be equal to 2 pi by lambda naught n naught t. So here maybe I should write just lambda. So here lambda means free space, okay? So now what is the extra phase that the ray has gained? So what is the extra phase या फिर phase difference? इसको हम कुछ भी बोल सकते हैं, phi बोल सकते हैं इसको, ठीक है? कि दोनों रेस में कितना phase difference आ गया, ठीक है? So that is going to be 2 pi by lambda t and ne minus n naught. But now we have to take the magnitude only, the sign not, we will not consider right now. So usually what we do is we write this quantity as lambda. So what is this lambda? Lambda is called as the optical path difference.
मैम आपने फेज गेन KZ लिखा है कि KT लिखा है?
हाँ, क्या चीज? मैंने KT लिखा है, मतलब it is KZ, but Z is equal to T over here. That is the distance we are moving inside the crystal. Okay. So I have written KT, but that has come from KZ only. Okay. So this
T thickness है.
T is the thickness of the crystal. Okay. So then the optical path difference I can write as is written as T and the difference between these. If T is inconvenient, then we can also write it Z. Okay. I don't want you to get confused because of that. Write it as Z because ये कहीं पे हमें use भी नहीं करना है formula. Just write T as Z because that will be easier to remember. T is unnecessarily an extra variable. Okay. So whatever the thickness of the crystal is, Z का कुछ नंबर दिया होगा, कुछ वैल्यू दिया होगा, and any n naught दिया होगा, या फिर हो सकता है कि birefringence का वैल्यू दिया हो. This is what equal to delta n, which was the birefringence. Okay. So like this, it might be asked कि अगर मुझे मेरे पास ये मटेरियल है और उस मटेरियल का birefringence ये है, तो मटेरियल का थिकनेस निकालो ताकि मैं हाफ वेव प्लेट बना लूं या फिर मैं क्वार्टर वेव प्लेट बना लूं. तो इस तरह का क्वेश्चन इन फॉर्मूलाज में आता है, ठीक है? सो दीज टर्म्स शुड बी क्लियर टू अस कि Z इज द थिकनेस ऑफ द मटेरियल एंड एनी दिया हो, n नॉट दिया हो या फिर बायरफ्रिंजेंस दिया हो. एनी n नॉट दिया है तो आई कैन कैलकुलेट दैट, आई कैन डायरेक्टली कैलकुलेट द डिफरेंस. अगर बायरफ्रिंजेंस दिया है तो दैट मीन्स दैट difference is given to me. Okay, so this formula I should know because इस पे बहुत simple और बहुत आसान questions बनते हैं और आते भी हैं, ठीक है? That they can ask you कि हमें ये पता होना चाहिए कि quarter wave plate के लिए क्या phi होता है, half wave plate के लिए क्या phi होता है, and if we know the formula then we can just find out कि what should be the thickness of the calcite crystal or any other crystal which is given in the question. So phi अभी हम पढ़ेंगे कि क्या क्या होता है different cases के लिए, ठीक है? So this is something you should maybe make a note that you should remember this. So now what we have is we started with these two rays and now they have sort of propagated through my crystal. ये Z distance propagate कर लिए and they came out on the other end of the crystal. Okay, so now on the other end of the crystal, what will I get is I will get EX is equal to EOX sine omega t plus phi, and EY will be equal to EOY sine omega t. So whatever phase gain is there, I am just adding that phase gain to the E ray, extraordinary ray में मैंने add किया है, and because that is the phase difference, so I can add it in किसी एक में भी मैं add कर सकती हूँ, because this is the difference between the two phases. So this is the actual difference कि दोनों कितना आगे या पीछे है. So I can either add it to one or to the other, but I am currently adding it to the E ray. Okay. So now if this kind of two oscillations I have, so what is this? This is just the problem जो हमने starting में पढ़ा था कि अब ये मेरा E ray है, which is which is P polarized, which simply means that it is oscillating along the X cap direction. Okay. And this is my O ray, which is S polarized, which means that the oscillations of the electric field are happening along the Y cap direction. And एक phi का मुझे phase difference दे दिया है दोनों इन beams के ऊपर. तो क्या है, पहले तो ये plane polarized beams है, second एक X के along polarized है, दूसरी Y के along polarized है, and third इन दोनों के बीच में phi का phase difference है. तो this is exact the same problem जो कि हमने first polarization के class में करा था. So how will I find out the state of polarization? I will write the equation of ellipse, which gives me the general state of polarization. So then what is the state of polarization? So I will get the equation of ellipse, which was that I have Ex by Eox square plus Ey upon Eoy square minus 2 Ex Ey Eox Eoy cosine of phi is equal to sine square phi. This was the general equation for any value of phi. But now we have to consider some cases कि phi का क्या value होगा तो हमें किस type का beam मिलेगा. Because see, हमारे हाथ में क्या है, we can change the thickness of the crystal and we can choose any value of Z to get whatever value of phi we want. तो हम phi कैसे introduce कर सकते हैं? We can only change two things. या तो हम crystal का thickness change करें या फिर हम crystal ही दूसरा लें जिसका birefringence different हो, है ना? These are the two ways. So the easiest way is that I change the thickness of the material, because finding out higher and higher birefringent materials might be problematic. I might have only few types of birefringence values, but Z is a completely arbitrary variable. I can choose कि उस particular crystal का कितना thickness allowed है. So I can tune the value of Z. Okay. So अब क्या है? I have the freedom to choose phi, and depending on different values of phi, I can actually produce different types of light on the other end of the crystal. Okay. So ये अभी purely repetition है, but it is necessary that we write it here so that in the next class when we will do questions and we will discuss half wave plate, full wave plate, we will मतलब कुछ बचेगा नहीं discuss करने के लिए, only I will just revise this a little bit. ठीक है. So अब इसमें क्या हो सकता है? I can consider case 1 where I can choose phi to be equal to 0 and 2 pi. तो 0 and 2 pi में क्या होता था जब हम पहले पढ़ रहे थे, that I had these two plane polarized beams 0 and pi में basically कोई भी difference नहीं होगा. I will get the same light on the other end, right? So I will get जो भी incident p polarized state था वो as it is बाहर निकल जाएगा. ठीक है. So what will I get? I'll get in this case same plane polarized light back. Now what is this light? ये कौन सी लाइट का मैं बात कर रही हूँ? If I go back to my diagram, तो जो मैंने ऑरेंज में लाइट वेक्टर ड्रॉ किया है, दिस इज माय इंसिडेंट प्लेन पोलराइज्ड लाइट. इस इंसिडेंट प्लेन पोलराइज्ड लाइट के दो कंपोनेंट्स में मैंने उसको ब्रेक किया. और उन दो कंपोनेंट्स में मैंने एक फेज डिफरेंस इंट्रोड्यूस किया एंड आई एम ट्यूनिंग दैट फेज डिफरेंस in my own way, that what phase difference I want, and by tuning that phase difference I am producing different types of polarizations on the other end of the crystal. Okay, so if I do not introduce any phase change, or if I introduce a phase change of 2 pi, then nothing happens. ये जो orange beam मैंने draw किया है, ये exactly यही plane polarized light बाहर निकल गई. ठीक है, तो this is the most obvious case. So now the second case could be that phi is equal to pi or 3 pi or 5 pi or something like that. So now what will happen is, if you remember, इस तरह का जब हमने केस किया था in the previous एक या दो क्लासेस पहले, तो हमें क्या मिलता है, लाइट का ओरिएंटेशन फ्लिप हो जा रहा था if you remember. तो यहाँ पर भी यही होगा that अगर मेरा जो इनपुट बीम है वो मैंने अगर ऐसे ड्रॉ किया था, दिस वाज माय इलेक्ट्रिक फील्ड E एंड इट वाज मेकिंग सम एंगल. सी ऑप्टिक एक्सिस तो मैंने x के अबाउट कर दिया, पूरा ही रिमूव कर दिया. सो दिस इज माय इलेक्ट्रिक फील्ड मेकिंग सम एंगल थीटा विद रिस्पेक्ट टू द y एक्सिस राइट नाउ. ठीक है, बल्कि थीटा यहाँ डिफाइन नहीं करता है, फिर यू विल मेक अ मिस्टेक. थीटा हम ये वाला डिफाइन करते हैं बिकॉज ऑप्टिक एक्सिस इज हियर, देन इट विल बी इजियर. सो दिस इज द थीटा जो मैंने फर्स्ट फिगर में भी ड्रॉ किया था. बट अब क्या है, मैंने दो कंपोनेंट्स में पाई या 3 पाई का फेज डिफरेंस प्रोड्यूस कर दिया. तो व्हाट विल हैपन इज, आफ्टर पासिंग थ्रू द क्रिस्टल, बेसिकली क्या हो जाएगा, आई विल फ्लिप द state of the polarization. How will I flip it? It will actually become this. That this is theta. So you can try doing this. जो ये वाला हमने इक्वेशन लिखा है, इक्वेशन ऑफ इलिप्स, इसमें फाई का वैल्यू पाई पुट करो. सो साइन का टर्म 0 हो जाएगा एंड कोसाइन ऑफ फाई क्या हो जाएगा, प्लस हो जाएगा. ठीक है, इट विल बिकम प्लस -1, सॉरी. सो दिस होल इक्वेशन विल बिकम EX by EOX plus EY by EOY whole square is equal to 0. Then उसका मतलब separate the two terms and you will get an equation of this type. You will get that EY is actually equal to, EY will be equal to minus EOY EOX EX. This is what you will get when you will substitute phi is equal to pi in the equation of ellipse. Let me say this is equation A. So equation A में substitute करके देखना, this is what you will get, and this minus sign will make sure that you have flipped the light. So basically first and third quadrant say you have flipped it and you have come in the second and fourth quadrant. But now the important point that you should remember is that this flipping only happens with respect to the optic axis. So optic axis kahan hai, is parallel to the x axis, isliye this angle I will consider. So if the phase difference is this, so typically क्या हुआ है, मेरा जो original light था वो कुछ ऐसा था. It was making an angle of theta. So typically मतलब मैंने क्या किया है, इस वाले पॉइंट को यहां से रोटेट करके मैं यहां ले आई हूं. तो I have done a rotation of 2 theta. Total rotation is of 2 theta, but again the angle the rotated light is making with the optic axis is theta only. Okay, so ये basically इस तरह के क्वेश्चंस आएंगे जब हम हाफ वेव प्लेट स्टडी करेंगे. देखो हाफ वेव प्लेट का मतलब क्या होगा, फुल वेव प्लेट का मतलब होगा कि तुम 2 पाई का फेज डिफरेंस इंट्रोड्यूस कर रहे हो. ठीक है, तो जो हमने ये फॉर्मूला ऊपर लिखा है, ये जो फाई है अगर 2 पाई आ रहा है तो दैट मीन्स आई एम यूजिंग अ फुल वेव प्लेट. फुल वेव प्लेट मतलब कंप्लीट 2 पाई वैल्यू. हाफ वेव प्लेट का मतलब हो जाएगा दैट आई एम इंट्रोड्यूसिंग अ फेज डिफरेंस ऑफ pi, which is half of the full circle. Okay, so half wave plate का मतलब वो हो गया. So this case is nothing but the case that when I am passing my light through a half wave plate, तो half wave plate can be in multiples of pi also. So it will always produce an extra, एक pi का difference it will always produce. ठीक है? So half wave plate क्या करती है? It will basically just rotate the angle of polarization. Half wave plate state of polarization change नहीं कर सकती है. वो प्लेन पोलराइज्ड लाइट को सर्कुलर या इलिप्टिकल नहीं बना सकती है. वो सिर्फ रोटेशन कर सकती है प्लेन ऑफ पोलराइजेशन का. A half wave plate can only rotate the plane of polarization of a p polarized light by the angle it is making with the optic, by twice the angle it is making with the optic axis. तो एक हाफ वेव प्लेट ने उसको प्लेन ऑफ पोलराइजेशन को 2 थीटा से रोटेट कर दिया. ठीक है? सो दिस इज नथिंग बट अ हाफ वेव प्लेट. एंड जब हम लोग हाफ वेव प्लेट के क्वेश्चंस करेंगे, सो दिस इज व्हाट यू हैव टू कीप इन माइंड. 2 थिंग्स यू हैव टू कीप इन माइंड. वन इज दैट कि जो रोटेशन होता है वो 2 थीटा की अमाउंट से होता है, एंड द सेकेंड इज कि रोटेशन हमेशा ऑप्टिक एक्सिस के अबाउट होता है. तो क्वेश्चन में यू शुड ऑलवेज गिव अटेंशन टू द फैक्ट कि ऑप्टिक एक्सिस कैसे डिफाइंड है. ऑप्टिक एक्सिस y के पैरेलल डिफाइंड है या x के पैरेलल डिफाइंड है. ठीक है? काफी बार ऐसा होता है कि ये एंगल मुझे दिया होता है बट ऑप्टिक एक्सिस तो x एक्सिस के पैरेलल है, और बच्चे यही एंगल यूज कर लेते हैं. एंड इंस्टेड ऑफ मतलब रोटेटिंग, अब तो ये एंगल मेरा 45 डिग्री लग रहा है, इसलिए दोनों केसेस ना सिमिलर लग रहे हैं. बट अगर जैसे मैं इस टाइप का कुछ डायग्राम कंसिडर करूं, that just a second, that my E vector was actually like this. Okay, टेढ़ा ही बन गया. E vector was like this, let us say. So it was actually making this angle. This is my optic axis. So this is my theta. Okay, but बच्चे क्या करते हैं, मतलब ये हो जाता है, भूल जाते हैं एग्जाम के पॉइंट आते आते. तो क्या करते हैं, that they want to rotate it but they do not rotate it about this. Instead they will rotate it about the y axis. So ये वाला एंगल दिया होगा क्वेश्चन में और पूछा होगा कि रोटेशन के बाद मतलब how you should get the light. So they will rotate it like this. मतलब they will rotate it by this much amount, but they need to rotate it by this much amount. And उससे फर्क पड़ेगा आंसर के ऊपर. ठीक है? So you have to always rotate it with respect to the optic axis, and this is wrong. Okay, so what we have to do is we have to rotate it like this. ये जो भी थीटा था, तो गंदा ड्रॉ किया. ये जो भी थीटा था, इतना ही थीटा मुझे यहाँ पे लेना पड़ेगा with respect to this. So that will be like this. लग नहीं रहा ये वैसा. So this should be equal to this when I'm rotating and not this angle. तो mostly question में ये angle दिया होता है, but then you have to subtract 90 from this and use this theta for calculation and not this green theta. नहीं करना है. We have to use the orange theta for calculation, which is this one. हमेशा rotation optic axis के about होगा polarization का. तो जब questions करेंगे तो you will notice that why I am putting a stress on this, because it really matters in questions क्योंकि बहुत सारे elements होते हैं and we have to keep track of all the elements, that how the polarization is being rotated, how it's being changed. So then it matters. ठीक है? So just make a point of these two things. That यहाँ पे क्या होगा? I will still get plane polarized light, but plane of vibration rotated by 2 theta. ठीक है? So अभी 9:12 हो गए हैं. So do you want me to continue for another 10 minutes or are you tired? Then I can stop. Is there anybody or
None next to each
everybody is
other.
left? Wait, let me check how many people. There are 8 people.
Hello,
So
ma'am.
if,
And we can continue.
okay,
Others have no problem.
okay. I thought everybody is left and I'm just talking to myself here. Anyway, so now this is what? This is a half wave
Ma'am.
plate. Yes.
Ma'am, how will we calculate the angle by which this is like rotating the axis?
When we will do the questions, no, it will be clear. That's why we'll do many questions on this. 7-8 questions we'll do on this topic. So when we'll solve the questions, by the wording of the question, you will understand कि incident field क्या angle बना रहा है. मतलब कुछ expression दिया होगा ना electric field का जो मैंने orange में draw किया है. Some field would be given to you, so you can find out that what is the angle it is making. An optic axis या तो x लिया होगा या y लिया होगा. So you can always find out that what is the जो भी ये plane polarized field है, how it is orienting. So we can find out that thing. That's not an issue. So जब questions करेंगे, yes.
I also have one more doubt, ma'am. Ma'am, before this, when you were talking about the direction parallel or perpendicular to optic axis, you were always like meaning about the direction of vibration of the electric field, right? Not the propagation of electric field.
No. Vibration of the electric field, propagation of the wave is always perpendicular to the electric field.
But I'm talking about like with respect to optic axis. Like for this E rays and O rays, when you were saying that it was perpendicular to the optic axis, parallel to the optic axis, you were referring to the vibration of E field, right?
Yes, because if you remember in the initial जब हमने class शुरू किया था ना, see this diagram. तो यहाँ पर we sort of describe the E ray and O ray in terms of its vibration also. तो हमने बोला कि जो electric E ray है उसका vibration क्या है? It's in the plane of incidence. It's going like this. And for the O ray, it is perpendicular to the plane of incidence. It's shown by dots, okay? So that is how we sort of told ourselves that when I'm considering an electric field which is, vibrating parallel to the optic axis, I'll consider that part of the electric field to be an E ray. And the one which is, the oscillations of the electric field are perpendicular to the optic axis or the plane of the incidence is the O ray. So यहाँ पर वो foundation, we have already put that foundation over here, okay? So using this idea, this understanding कि E ray and O ray जो होती है उनका जो polarization होता है वो actually perpendicular होता है एक दूसरे के, ठीक है? So that is what you have to remember कि they are perpendicular to each other. अगर एक ऐसे vibrate कर रहा है तो दूसरा will always vibrate perpendicular to this in a uniaxial crystal. So with that understanding, in this current जो ये topic हम study कर रहे हैं, we saw that the EX component of the field is actually going to act like a E ray because it is going to vibrate parallel to the optic axis, and the Y component of the electric field is going to act like an O ray because it is going to, vibrate perpendicular to the optic axis. So, but even अगर इतना भी visualize नहीं हो रहा है, so the least you can visualize is that you can visualize two components of the electric field which are propagating with different velocities, and therefore they have an inherent phase difference between them. Okay, even if you cannot remember or it's difficult to visualize that what is E ray, O ray, itna bhi ek basic understanding that my material is breaking the refracted ray into two rays, and the two rays are traveling with different speeds, and therefore when they are coming out of the crystal and I'm sort of combining those two to form some kind of a light on the other end, so I can change the the phase difference between these two, so that जो भी बाहर मुझे light मिल रहा है, when I will combine the two beams, then I should get different type of polarization. तो इसलिए मैंने बोला कि ये अंडरस्टैंडिंग जितना आता है यू टेक इट, नहीं आता है तो बहुत बेसिक चीजें से भी हो जाएगा, बिकॉज क्वेश्चन किस पे आएगा? क्वेश्चन आएगा इस फॉर्मूले के ऊपर, जो बहुत easy formula है, extra phase difference. But how will you appreciate this formula when you understand the phenomena of birefringence and double refraction? तो जितना समझ आता है लेक्चर से you take it, but जो बहुत जैसे questions करेंगे and there if you face some problem, then we'll figure out कि how to make you understand that solving part, okay? Because ये theory ना बहुत vast है. If you go into the propagation of electromagnetic wave in uniaxial crystals, biaxial too is not even a part of your course. Uniaxial is itself is like you have to do a lot of, properly you have to understand it using electric displacement. So basically जो भी material है उसमें electric field fall हुआ, फिर कुछ polarization generate हुआ inside the material, and then you have some electric displacement vector comes into picture, and then you study the orientation of that, and from there you study the E ray and O ray, that how they come about. So that is a completely very vast theory. So wo is good if we want to understand this more, but we don't have that much time here, right? The classes are only for 6 months. So from question point of view, I think this is going to be sufficient. So I just want to finish this discussion, all the cases, so that in the next class we can, try solving some questions, because that will make it more clearer to us. Okay, so this is the case when I introduce phi as pi or 3 pi or 5 pi. So now the next case could be that I introduce phi as pi by 2 or 3 pi by 2 and like that. Okay, so case number 3 can be that the phase difference I introduce is pi by 2, 3 pi by 2, and so on. So what is this? This is a quarter wave plate. So I will write a half wave plate and quarter wave plate in the next class also. So I'm not writing it here, but what this means is that 90 kya hota hai? 90 is 1/4 of 360, right? So therefore a quarter of the complete circle. Okay, so this is a quarter wave plate when this kind of a phase difference is introduced. But then there can be two cases in case number 3 also. Okay, so एक case हो सकता है कि जो मेरी incident light है, अगर if I go to the original figure, so this theta, जो orange में I have drawn the theta, if this theta is exactly equal to 45, okay, then what will I get? I will get a circularly polarized light, because if this theta is equal to 45, so my EOX and EOY would have sort of equal magnitude. जो E vector है, basically देखो ऐसा हो जाएगा. If I say that this whole magnitude of this vector, now think in terms of vector, okay? ये जो मैंने पूरा एक vector या फिर जो line draw किया है, if I say कि उसका total जो length है that is equal to E, or let me consider this from the origin. If I say this is origin, so from origin to point A, तो OA जो है उसका length E है, then what is going to be the length of OX and OY? So then OX is going to be equal to E cos of 45, no, cos of theta लिखते हैं, cos of theta, and OY is going to be equal to E sine of theta. So if theta is equal to 45 degree, then the length of OX vector and the length of OY vector are going to be equal. And when they are equal and the phase difference is pi by 2, then what is that? That is the circularly polarized light. But if the theta is not equal to 45, but it has some other value, then OX and OY ka length equal nahi aayega. And then in that case, what will I get? I'll get an elliptically polarized light. So in case number 3, okay, so if this is equal to pi by 2, 3 pi by 2, and incident theta is equal to 45 degree, that is जो कि plane polarized light fall कर रहा है, it is making an angle of theta with respect to the optic axis. In that case, I will get a circularly polarized light outside on the other end of the crystal. And if phi is equal to pi by 2, 3 pi by 2, and so on, but incident theta is not equal to 45, then what will I get? I will get elliptically polarized light. ठीक है, so ये सारे cases तो हम पढ़ चुके हैं, but now there are 3 more very simple cases, so let us quickly do that. Actually, this was case 4. So case number 5 is when theta. अब now अभी हमने cases किस पे study करे? Phi के ऊपर, ठीक है? Phi क्या है? Phase difference between the two x मतलब 2 e ray and o ray जो है उनके बीच का phase difference जो हमने introduce किया है उसके ऊपर consider करें. But अब हम cases consider कर सकते हैं theta के ऊपर भी. And theta क्या है? Theta is the angle my incident light is making with respect to the optic axis. Okay. So if this theta, अगर मेरा जो इंसिडेंट लाइट है इट इज कंप्लीटली पैरेलल टू द ऑप्टिक एक्सिस, मतलब थीटा इज इक्वल टू 0 और 180, तब क्या होगा? या फिर थीटा इज इक्वल टू 90 या 270, तब क्या होगा? ठीक है, सो दीज आर द 2 अदर केसेस वी हैव टू स्टडी. सो इफ थीटा इज इक्वल टू 0 या फिर 180 डिग्री, सो व्हाट दिस मीन्स इज दैट E is actually parallel to optic axis. So जो मैंने क्रिस्टल अभी बनाया था ये वाला, उसमें I had, this is my X or the optic axis and this was my Y. So now what I'm saying is that my electric field is actually like this. This is my E vector, so that the theta is equal to 0. So in this case क्या होगा? There is no O ray. Because O ray होने के लिए कोई component होना चाहिए which is perpendicular to the optic axis. So in this case, I will not have any change in the polarization because polarization change करने के लिए मुझे 2 rays चाहिए जिनके बीच में phase difference हो. But इस case में तो सिर्फ एक ही ray है, okay, which is parallel to the optic axis. इसका कोई component है ही नहीं, इसका कोई non-zero component नहीं है along Y. Therefore, I cannot change the state of polarization for such an incident light. Okay, so here, no double refraction. So only E ray is present, no O ray. Therefore, plane polarized light will simply pass through. यहाँ पे कोई भी double refraction नहीं हुआ, so there is no way that we can change the state of polarization. So no polarization change. Okay. So now let us consider case number 6. So case number 6 हो सकता है when this theta is actually equal to 90 degree or 270 degree. That is, the E field is actually perpendicular to optic axis. So now this is my crystal. And this is my electric field. And this is my optic axis along X. And this is the Y axis. ठीक है, so अब क्या होगा? मेरे पास कोई E ray नहीं बनेगा because there is no component of this beam, non-zero component, which is parallel to the optic axis. So again, this beam will just, pass without any change. तो जब भी polarization change करना है, we need 2 components जिनके बीच में I will introduce some phase difference. So here I will have no component along X. Therefore, only O ray is present. So no change in polarization. Okay, so this is just similar to the previous case. Now case number 7 and the last case is that this phi is actually not equal to 0, pi by 2, pi, 3 pi by 2 या 2 pi. इनमें से कोई वैल्यू नहीं है, but it has any other value. Any other value. ठीक है, सो मतलब इसके जो क्वेश्चंस आएंगे उसमें वी हैव टू कंसिडर बोथ ऑफ दीज थिंग्स. वी हैव टू कंसिडर व्हाट इज थीटा, the orientation, मतलब basically the angle the incident light is making with respect to the optic axis, and then phi, that what is the phase change the beam is experiencing after going through the crystal. So ये दोनों चीजें ध्यान देना पड़ेगा for solving the questions. So the last case is जब ऊपर का कोई भी केस नहीं हो रहा है, मतलब the phi has any other value, जैसे let us say phi का वैल्यू 82 डिग्रीज है, ठीक है, या फिर 67 डिग्रीज है. Phi is equal to maybe 57 degrees. So any other value of phi, leaving all these values, will give us elliptically polarized light. Okay, so these are the cases. So in a way, we have roughly covered what is a full wave plate, what is a half wave plate, and what is a quarter wave plate. But I'll also discuss it a little bit in the next class, and then we'll solve questions. काफी सारे करेंगे, so that we understand how to apply all this that we have studied. So case 1 is nothing but a full wave plate जो कहीं पे use नहीं होती है because it doesn't change anything. So full wave plate means that, let me write it only. So what is this? This is a full wave plate. कहीं पे यूज नहीं होती है because it doesn't change any polarization. This is a half wave plate. तो half wave plate किस लिए यूज होती है? For rotating the plane of polarization of a plane polarized light. Half wave plate cannot produce a circularly polarized light. It cannot produce an elliptically polarized light. All it can do is rotate the angle of polarization about the optic axis. जो भी optic axis है उसके about it will rotate it by the angle 2 theta. ठीक है, and case 2 theta का मतलब है ये total 2 theta. ठीक है, and case number 3 is this one. So case 3 and 4 actually both correspond to a quarter wave plate. These two correspond to a quarter wave plate. So quarter wave plate का काम क्या है? Quarter wave plate will introduce 1/4 of the total circle. So that is 1/4 of 2 pi. So it will introduce a phase difference of pi by 2 or multiple of pi by 2. And now depending on the incident beam, कि beam is incident at 45 degree या फिर किसी और angle पे, a quarter wave plate will give rise to either circularly polarized or elliptically polarized light. Okay. So ये बाकी जो सारे cases हैं, केस नंबर 5 या 6 हो गया, वो हमें पता होने चाहिए सो दैट यू नो वी नो कि थीटा के वेरिएशन से क्या हो रहा है. ठीक है, तो थीटा का भी हमने सारे केसेस कर लिए. इफ यू कंसिडर इन अ वे, अगर थीटा 0 या 180, मतलब थीटा अगर एक्स के, अगर इंसिडेंट फील्ड एक्स के पैरेलल है तो हमें पता है पोलराइजेशन चेंज नहीं होगा. इंसिडेंट फील्ड वाई के पैरेलल है तो हमें पता है पोलराइजेशन चेंज नहीं होगा. और इन दोनों के बीच में कहीं पे कुछ ओरिएंटेशन है इलेक्ट्रिक फील्ड का, either in the first quadrant, in the second quadrant, जो भी orientation है. तो depending on the value of theta, you know, different sort of things we'll get. फिर theta fix होके फिर phi, मतलब it's, मैं बहुत देर से बोल रही हूँ, मुझे समझ भी नहीं आ रहा what I'm saying. But are you understanding something? When we'll do the questions, then it will be clear. Okay. So बहुत पढ़ लिया आज, बहुत लेट भी हो गया. ठीक है, सो थैंक यू फॉर योर पेशेंस. सो आई विल स्टॉप द क्लास नाउ, बहुत लेट हो गया है. ठीक है, सो नेक्स्ट क्लास में वी विल ट्राई टू सॉल्व क्वेश्चंस ऑन दिस. एंड पोलराइजेशन में फिर एक क्लास टॉपिक ही रहता है विच इज द ब्रूस्टर एंगल. उस पर मुश्किल से एक क्वेश्चन आया होगा कभी, बट इट्स वेरी इजी. सो वी विल डू दैट. वी विल ऑल्सो डिस्कस that how we can have polarization changes by reflection. वो उसी में आ जाएगा sort of. बहुत छोटा टॉपिक है, so we'll try to finish at least the polarization section in the next class so that we can start interference after that. ठीक है, तो मैं एक एक्चुअली टेस्ट लेने का सोच रही थी क्योंकि काफ़ी कोर्स हो गया है लास्ट टेस्ट के मुझे सॉल्यूशंस भी देने हैं, तो टाइम ही नहीं लग रहा है. मैं डेली सोचती हूँ आई डू इट टुडे बट समथिंग और द अदर कम्स अप. सो वी हैव डन टेस्ट टिल रेजोनेंस, राइट? सो वेव इक्वेशन से लेके वी हैव डन टिल डॉपलर. ठीक है, इतना हो गया है. उसके बाद वी हैव डन द पोलराइजेशन. ऑप्टिकल रोटेशन अभी नहीं पढ़ेंगे, उस पर कुछ आता नहीं है. So polarization, linear, circular, elliptical, and double refraction, and all the topics from wave equation to Doppler effect. Okay, so you start revising them a little bit. Then I'll announce a date to have a exam for that. Then the last third class test हो सकता है interference, diffraction और जो बाकी ray optics में बचता है वो topics I think. क्योंकि if I'll also include interference and diffraction in this paper, then बहुत ज़्यादा syllabus हो जाएगा.